Hello, everyone. My name is Kanushri. Before we dive
Mhm.
into our IBDB Math Masterclass, I'd like to take a moment to introduce you to the organization making this session possible. Let's Unbound. Let's Unbound is dedicated to empowering students across more than 25 countries by fostering STEM skills, life skills, and college readiness. Our mission is to help students achieve their life skills by 18 and life goals by 35 through personalized learning and mentorship. With programs ranging from skill development, gifted test, college prep to Ivy League readiness. Let's Unbound has taught over 4,000 students, conducted more than 125,000 hours of teaching, earned a global 4.9 out of 5 rating. By combining innovative teaching methods with strong mentorship, Let's Unbound helps students realize their potential and make a positive impact on the world. So, as we begin today's masterclass, remember you're building skills that will help you excel far, far beyond the test in college, career, and in life. Over to you, Bhavya Lakshmi.
So, IBDP Masterclass and the main essence is from concepts to the perfect seven, right? So, let me just give you an introduction about IB, the assessment, the curriculum, everything, and then we will see how our session would be. So, what is this IBDP program? Yes, it is an international pre-university program. So, students basically from age 16 years to 19 years will be enrolled in this. And this is globally recognized and accepted by top universities throughout the world, I mean. And yes, this focuses on not just learning from the book and giving your exams. So this focus on conceptual understanding, critical thinking, and it has global perspectives. Even if you are a student of IBDP, the problems will be you can much related with the real life situation, like the reality world, right? And this is IBDP in a short way. Now, IBDP curriculum at a glance. So the IB core has TOK, which is theory of knowledge, EE, which means extended essay, and CAS, that is creativity, activity, and service. So these are some core things every subject will have. So these are 6 subjects you can see: art selectives, language and literature, language acquisition, individual and society, sciences, and mathematics. So mathematics is what that will be the essence of today's topic, like how to achieve the perfect seven. And yes, this concept or whatever a formula I'm going to tell you will be applicable for your other subjects too, right? And IPDP assessment and evaluation. So there is two kind of assessment you can see: external assessment, which is the final exams we will give in our centers, like final exams, and it will be evaluated globally. Then internal exam assessments will be there. These are the course which are moderated by external members. So you will be doing it in your uh, within your school. It's not like a global exam, but the moderation will be done external. And how the marks will be awarded. So it's not just about final answer. So the IB examiners expect interpretation of the problem given or a question if you're in other subjects. And then logical working and method. As it is it's a global curriculum, right? So we might have using a lot of methods, right? So any acceptable and correct method is you will get a full mark, right? It's not about only this IBDP method will work. And clear justification and communication. So this communication is a very important criteria in IBDP. Mostly every question they will assess you how you are able to justify your answer or how you are communicating the answer. So these are things which is going to be playing a key role to imperfect self, right? Now, finally, the grading scale. The IB grading system, it's not about 100% of marks. So this is something have the scale from 1 to 7 and 7 being the highest. And yes, you have 6 subjects. So 6 times 7 is 42. But you can attain extra points like 3 bonus points. Depends on the work, the quality of the work that you are doing in your TOK and extended essay. So your maximum score in your diploma would be 45, right? Now, so IBDP math components, that is what will be the curriculum, this things inside that. So you have number and algebra, functions, geometry and trigonometry, statistics and probability and calculus. And this function calculus, right? This covers the most weightage. Like calculus will be the 40% of it. And yes, in calculus, you should understand functions. And number algebra, geometry, trigonometry, they are also important. But comparatively, calculus and function is the highest weightage thing, right? And also our IBDP problems that we face in exams, right? In one particular question, maybe it might carry 21 marks. It might cover, like, it will be a trigonometric problem. It assess you the skills that you have in number and algebra. You might use calculus. So many things will be incorporated in one single question. So it's not just about this concept. I should be aware, then I can get 20 marks. Not like that. Every skill is important. And here, so coming to the perfect seven, how to get this? And my formula that I would suggest today is getting the perfect seven should have these three things: conceptual clarity, smart application, and then clean working. So conceptual clarity in the sense, um, like if you're learning something topic called calculus and like how to find the surface area of a solid, right? Or a minimum or an optimization. So whatever thing, universally it's the same concept, right? So the concept clarity should be there and how you apply the problems. So when you see the IBDP problems, it will not be like as the problems that we found in other curricula. This is something, it always comes with a real life context, right? So we should think. So you know the concept, how to apply and when to apply this. That is important. And then a clean working should be. So clean working in the sense, sometimes we will use GDC. Sometimes we will do analytically. Sometimes some people like you will be doing some things in head itself. Like quadratics, if you do a lot, you will automatically say the answer just by looking at the numbers. But yes, you should show the working that you have done. Even you can do something in head or using GDC, right? So the working is important because every step in your presentation will carry a mark. It's not just about you had the final answer, right? So this is our foundation for today's session. And now, just a second. Yes. So key concept, sorry. So seven, not just solving like a random solving, how is solving like a seven scorer. So that is the main of this session. And our pathway today will be, I will give you some key concept because in this session, I will walk you through a sample problem, which is the past year problem from IBDP, right? And the three formula, right? Three-step formula, how to apply this in the sample problem. And first we will do the key concept just for a refresher, like you know the concepts behind a problem. Then a problem breakdown, read the problem, understand, right? That one. And how to give a structured solution here, right? So that's it. So be ready with pen and paper and also have a calculator, not just like a GDC is not needed, just a scientific calculator is enough here, correct? Okay, so the key concept in our today's problem would be formula. Yes, we will be using some formula, and yes, we have formula booklet in our IBDP exams, right? But I will not suggest like every time you go to formula booklet and refer this, because by consistent practice, you might be aware of most of the formulas, right? And also the problems will be not directly from your formula booklet. You can just use as a reference. So exact copy the formula will not work every time, right? And making a variable a subject, this is one important thing most of the DP problems like higher level or standard level will have. And then in today's problem, we will be applying derivatives concept and also how to reason out like when you're communicating your answers, right? So these are the key concepts. And I think you can relate this. You might be coming across these things even in your practice or your unit test or a slip test, right? Yeah. So before starting, I have this question. So everyone take your notebook. I hope you're with notebooks and solve this question. I will be giving you a few seconds and you can show me a thumbs up if you have completed it, right? So just do what, read the question and solve this problem. It's just a two-step. Okay, I can see many of you here, so do try solving this. Or if you can do it in head, that is also fine because it's that simple. Okay, any of you got your answers? It might have fractional and powers, so you can't put it in the chat. So just try and raise your hand if you have completed. Okay, many people are still solving, it seems. That is so simple. Okay, maybe I can give you 30 more seconds. And you can raise your hand if you have completed, or this is a simple mini check question. Okay, so let me reveal the answer here. So this is a testing the skill like how to make a single variable equation, right? One side will have a single variable, so making a variable as a subject. And this is the answer. I hope you might got this. So be proactive and be active in the session. Like if you're, then only I can understand, okay, students are really listening today, right? Okay, how many of you are really in the class? You're present, you're listening. Can you raise your hands? Oh, cool. Sanvi is listening. Iram Khan, if I'm not wrong, yes, listening. Superb. So two of the member. Okay, that's cool. Right then. And this is the answer. So volume of cylinder formula is this, pi r square h equals 45. And then this case, I told that the question is given, its radius is x. So we should put pi, r should be replaced with x. And then we should make what is h in terms of x, right? So h should be there. And I will divide by pi x square on both sides and I will got this expression. Correct? So, right? And now we are into the real challenge for today, which is this is a sample problem. It's a past year problem from IBDP. And you can see here a solid shown in the following diagram is comprised of a cylinder and two hemispherical ends. The cylinder has a height x centimeter. The hemispheres fit exactly onto either end of the cylinders, right? So cylinder and hemisphere are perfectly overlapping on each other. That suggests you that radius of cylinder and hemisphere are x and height of the cylinder is h, right? So this is what we observe. Now, this is the description of the problem and it have many parts as you know, right? So let's go to that. Okay, let me take the pen. Right. Then they give the volume of the cylinder is 45 centimeter cube, the cylindrical part alone. And first part, show them the total surface area that is denoted as S centimeter square of the solid is given by this expression. Then the total surface area of the solid has a local maximum or a local minimum. It's a statement. Okay, they are telling something. So this is going to be a crucial part. A minimum or a maximum when x is equal to a. So a is an unknown. We might be calculating that. So that subdivision is find an expression for ds by dx. First derivative of your s. What is s? S is total surface area of the solid. And hence find the exact value of a. Right? Though it's a calculated paper, exact value, we should know some analytical algebraic manipulation here. And then C part, find an expression for d square s by dx square, the second derivative. And then using the second derivative of s, you have to justify that s is minimum when x is equal to a. And find the minimum surface area of the solid. This is a clear optimization problem, right? And also it involves first derivative, second derivatives, we have to prove the part, right? So let us break down all this together. And yeah, so what are the skills we need? For first part, we need algebraic manipulation. I can, oh, that's great. I can see Rudra's answer here. Which book would you recommend? Okay, I will take your questions towards the end. Okay. Yeah. So differentiation, solve for stationary points, and then interpretation. All these skills in one single question. And this question is something about 14 or 15 marks. Correct? So let's see how to score completely. And this is the first part I'm going to solve. So finding to prove that S is equal to this expression. Okay, let me start how to calculate the surface area of the solid. Okay, that is denoted by S. External surface area. So the surface area, which is external, not internal, right? So cylinder part, like if you see the word surface area, you go to the formula booklet, it will say something like 2 pi r square h plus 2 pi r square, and that will be trapped. In this case, it's something different. It's not a standard cylinder. The two areas or the two circular parts are covered at inside, right, in the solid. So we will do 2 pi r h alone. Only the curved surface of the cylinder is considered here. And also hemisphere, the circular part get inside. So two hemispheres are there. So we should do 2 times. And what is hemisphere surface area? Pi r square. Right, here a problem. We have learned through r for radius. But in this case, they give h as h, but x radius is x. So I should be careful and let me change my r to x. Okay, so it's 2 pi r h. So 2 pi x h. And then 2 times 2 pi r square, but my r is x. Okay, so 2 pi x square. And then you simplify this 2 pi x h plus 2 times 2 is 4 and pi x square. But my expression something has a fraction. What is the problem? You observe this. It is S is only made up of one variable, and even though they didn't mention, every time we will be doing the same. If you're making a function, it should be of only one variable. How can I do that? Some clue will be there. They give volume of the cylinder is this. So let's use it. What is volume of cylinder formula? This is what I give you in mini check, right? So, and some of you has answered correctly, like Rudra gave it in the chat. I hope others also know this, correct? So, volume of cylinder is 45, they say. As per the formula, if I apply the formula, it's pi x square h equal to 45. So, it's easy to, like, my S was given only in terms of x. So, I'm going to remove this h. That means replace this h, which is 45 by x square, right? And that's simple. 45 by pi x square, actually pi x square. And I'm going to put it here. 2 pi x in place of h, you put 45 by pi x square. And then 4 pi, here no change, no h, no problem there, correct? And moving to simplifying this, 2 pi times 40, okay, we can cancel pi and pi. And 1x and 1x. So 90, and in denominator we have an x. Then 4 pi x square. Exactly, we got the same. So the show that part is done. And you have to show your clean working, not too many steps. So like we can do this in 3 steps, correct? That's simple. And now we are moving to the next part. I hope everyone got this. This is kind of simple, right? Here. The total surface area of the solid has a local maximum or a local minimum at a point when x is equal to a. Find an expression for ds by dx. Find the exact value of a. So we proved s, and we should find first derivative, and then we should work for a. So let's do it one by one. This is our s. And d, okay, I will suggest you this thing when you're writing so that we can reduce some careless errors. So 90 by x, you can write it as 90x square minus 1. And 4 by x square is not a problem. When you have your variable, that you're going to differentiate, right? If it is in denominator, please write like this. And it's a simple power rule. yeah, you can refer, you don't want to refer actually formula booklet, but if you differentiate x power n, it will be n times x power n minus 1, right? And we can start our differentiation. So this will be multiplied here, minus 1, which is minus 90 x power minus 1, again a minus 1 minus 2. Then if you differentiate this, 2 will be multiplied, 8, pi is constant, so keep as it is, and x, 2 minus 1 actually, which is x. So minus 90, and write it in standard form back. This is not appreciated, this is not expected one. Minus 90 by x square. If you like, write in the simplest standard form, that is what will gain you the full mark, right? And 8 by x. Okay, so this is my s. And where is your ds by, like your differentiation start? You should mention. Here it starts, ds by dx. So mention these notations also properly. Okay, and they have asked for ds by dx, but most of you might solve s prime, something like that. So don't do that. Whatever they give, go with the same notation. Again, these simple things will give you, sorry, yeah. Okay, so that's it. B first part. Actually, I but my working got. Okay, so I hope you have understand this. And moving for next, find the exact value of A. So we just worked on ds by dx, and this is what we got. And they said find to A, and to find A, what is the clue given for finding A? So A is a point where your S attains local maximum or a minimum. This is what a clue about A is given. Local max or local min. So they are not sure whether it's a maximum or a minimum. So it's just any one of the extremas there. So how can I find at x is equal to A means? So your ds by dx will become 0. This is the concept. Like we must know. Formula booklet can help us. Or even GDC that will be, yeah, you can refer. So ds by dx equal to 0 at some points and solve for x. This is what we will do whenever we want to solve for local extrema, like local maximum or a min, right? But this time they said at A it was thing. So what you have to do is ds by dx at x is equal to A, and you should put it to 0. Okay, so minus 90, when x is A, you should put A square plus 8 by, right? You have to plug in A and then you should solve for A only. And we will get minus, okay, this is equal to 0 because we are calling for local max. So minus 90, you can simplify this, like multiply by A square throughout, right? These things you don't want to show, but I'm just showing it for your reference, okay? You can directly go to the step that I'm going to write now in a purple color. So A square cancel, minus 90 plus 8 by A cube equal to 0. And I want to find what is A. You know how to do this? Simply make A as a subject. So first 8 by A cube equals 90. Then you divide by 8 pi on both sides. And you will get A cube is 90 divided by 8 pi. And here one important thing you should know. So A cube will transfer to the other place as a cube. So you can mention like this, cube root 90 by 8 pi. So you might in a hurry, you might write it like A equal to like this, right? When you're writing, you're trying to mention it's a cube root, but you might, when you come back and check, you might think it's 3 times or something. So try avoiding that. And I will suggest, yeah, this is also accepted, but make sure you're writing the surd notation properly, right? Or you can write A is equal to 90 by 8 pi, like a exponent notation. That's fine. Both are accepted. Okay. So yeah, we find the value of A. Here is what a local minimum or a maximum will come. Right. Now C part, this is the final part. And find an expression for d square s by dx square. Use the second derivative to justify that s is minimum when x is equal to A. Find the minimum surface area of the solid. So let's find it out, this d square s by dx square, and let's do it step by step. Okay, we have this ds by dx, again differentiation. And as I suggest, you can go with this form, like writing in this. If your variable is in denominator, please do this 8 by x. And then you apply the, what we say, uh, okay, sorry. So you can apply the power rule, right? So you will multiply minus 2, minus 90 and minus 2 will become 180. X power what? I need your responses now. Okay. X power, yeah, I got your new message. Yes, perfect, Rudra. It's cube root 45 by 4 pi. For A, oh, you simplified that. 90 by 8 pi. Yeah, we can simplify under the cube root. Yes. Okay, now coming to x power 180 x power what? Oh, no one? Come on. Okay, I got 180 by x. Okay, Rudra gave the final answer. Okay, so yeah, final answer is that one. So here I suggest like minus. Okay, Sanvi. So 8 pi and x when you differentiate it will become 1. So yes, final answer is 180 by x cube plus 8 pi. Well done, Rudra. And I think, Sanvi, you tried to mention x power negative 3, right? Okay. So it will go by divide, but you tried even in this chart, right? It's not easy to type math things, but good. And yes, others, come on, you can also. Okay, Sanvi, understand. So typing error might happen. So that's superb. Well done. And others, come on, you can also try. Some simple question I will ask you. Okay. So this is our, wait, what? D square S by dx square. So where you start differentiating, this is actually your differentiated had been applied. So here you put D square S by dx square, right? And that's it. First part is over. Coming to second part. Use the second derivative to justify that S is the minimum when X is equal to A. That is a key concept, which is very important. Your first derivative will tell you, like first derivative equal to 0 and you solve, right? You will get some answers. That will tell you, okay, these places I have either local maxima or a local minima. So it's not sure. It will just tell you, okay, these are the places. But your second derivative will tell you, okay, at this point you have a maxima or a minima. This will give you a strong uh, conclusion. Okay, so both the things are very important. Now, use the second derivative to justify that S is the minimum and X is A. We already find A. Anyone remember what is A? Okay, it's a big thing we did. And yeah, so here they didn't say exact value. Previously we did exact value, but that is much complicated, right? So we got something like 90 by, okay, a 90 by 8 pi whole power 1/3, right? Even if you put it in calculator, it will take a long time. No problem. You can approximate to 3 decimal places because they didn't mention give exact value, right? So what is x approximately? Can you do it in your calculator and tell me this? Let me see how many of you are correctly using your scientific calculator. Okay, come on, this is just calculator thing. You can try. Okay, so maybe I can reveal. I hope you might be grabbing your calculator. So it's around 1.53. So your A is approximately 1.53. It's important you should use, okay, I think I got it. It's 1.5. Okay. So, but IB, what they expect is for a full score, 3 decimal places is like 3 significant figures is needed. Okay, so 3 figures. In that case, you can, right? So 1.53 we can take, and you just apply this. And if you're, let me tell you this. So all you have to do is d square by dx square at your 1.53 we should evaluate. It's not about a number. All you need is this particular thing is positive or negative, and that will tell us it's minimum or maximum. Okay, why? That is a key concept. Let me reiterate this to you. So uh, we know concavity, right? The second derivative will decide the concavity. It's concave up or a concave down. When it is concave up, when your second derivative at a particular value is greater than 0 means you go there and look, it will be facing up. And if it's less than 0 means it's going down. But it's not about concavity we are doing. We are going to justify the minimum maximum here. So if your d squared s by dx square, let's see what happens here. And then we will come to this. Just, yeah. So this is, you will substitute 180 by 1.53, the whole cube plus 8 pi. 8 pi is positive, 180 is positive, everything is positive. No chance of getting negative. Don't go to the calculator and waste time. So you can just say it's greater than 0. Right? So d square s by dx square 0 greater than 0 means it's concave up. Concave up means that point should be a minimum, not a maximum. So mostly we'll do this error. Oh, greater than 0, it's maximum. No. It tells about concavity, it's being up or down. But the minimum, but its extrema would be the minimum point. Okay. So this suggests your S is minimum at x is equal to a. Actually, here, sometimes IB will suggest you're working as a justification, but still you can give your justification simply like as the second derivative at the point is positive, it suggests that it says that curve is concave up. In a concave up curve, the point will represent a minimum. So in that case, you can justify. Okay. But if I see this particular marking scheme have, they don't want you to make a sentence. But anyways, you just give a sentence. Or sometimes this just your working itself will act as a justification. Okay. Right. And into the final part. Find the minimum surface area of the solid. Your S is 90 by x plus 4 pi x squared. Okay, coming to this. They are asking minimum surface area of the solid. Yes. So what we know about the minimum, S is minimum at this point only. At x is approximately 1.5. Correct? So don't substitute it. We have many things. Don't go for ds by dx or d square s by dx square. Surface area is this, right? You have to substitute that. So picking up the correct expression is also important. So 90 by 1.53 plus 4 by 1.53 square. I know some of you students, IBDP students, what you will do is you will directly go to GDC. You will have this stored, correct? But even though you store, you have to write this so that the IB examiner, right, those who evaluates, they will understand, okay, you did substituted 1.53 into yes. Right? So show this, you pick this equation and you plugged in. Then directly, this is also not one, but mentioning this and 1.3 is important. And then directly from the calculator, we can mention this. So you will get approximately going to 3 decimal places. And you know what? I did an error. So you should not do that. Whenever you substitute this approximated value. So I'm putting 1.53 means here also should put approximate because this yes is not an exact one. So there itself you should put approximation symbol. So that is where keen a perfect 7 might be. Otherwise, they might score you A0 than A1. We are aiming for A1 in every step. Okay. So this symbol will suggest you. And that's it. We complete this problem. And here, there is a key takeaway. And before that, do you have any questions like whatever we solved? Maybe solving part? This is the easy question I pick up for today's masterclass. Anyone have any questions on this particular problem side? Okay, I will wait for 30 seconds. Okay, it seems like no questions. Maybe the question is simple. Yes. So the key takeaways for today, or else I have a separate board for your question section. We can do that place also. So the key takeaways, uh, first you read the question, understand, do it twice also, interpret, like that means what the question is asking and the concept you need. So this will set your path very clearly so that you know at what steps what to we need to do. And then plan and solve. Apply the concept systematically so that you will be giving a clean working. You won't be, oh, I might have done this before. So plan and solve, take your time, maybe it might take you less than a minute. Then justify and conclude. Wherever they are justifying, asking for justification, don't skip that. Mostly when we got a final answer, X is this, A is this, K is this, we will skip. But there will be a word called, say, justify your answer or communicate your answer something. So you might miss it. So do that part also. That will complete the exact score and you will get a full mark. Correct? So these are the steps, and you can start implementing not only in an exam, even after immediately after the session. If you are going to practice tonight, you can do that. These three steps, and yeah, even in your slip test, you start doing that. In final exam, obviously, your brain will think in this way: interpret, plan, and solve, justify, and conclude way. Okay, right. And I have a question for you, like a very simple, based on a question, a concept we applied in today's class, right? So be ready for it and send your answers in the chat box. It's just you have to mention the option. Are you ready for the exit ticket question? Okay. I can see 6 of you here. Okay, cool. Sanvi is ready. Right, we can move. Okay, read this. I'm not going to read it. And send your options. It's A, B, C, or D. Okay, come on. No one, really? Okay. So the consistent uh, student who will be giving the response. I'm naming out Sanvi and then Rudra, right? Others also, but yeah, come on. Just give it, it's wrong. That's not a problem. Okay. So, oh yeah, I got here. Okay, I got it. So Sanvi said D, Adi said it's A. So yeah, it's A is the correct answer. Well tried, both of you. First, I should appreciate for trying this because it doesn't prove whether it's a max or a min. It will just tell you at this location something is there, but it won't be strong enough, strongly conclude that. Okay, so second derivative will tell whether exactly it's a peak point or is a lowest point. Okay, tell me if you have any questions, and I already had a question from Yeram Khan. I hope he's there. Yes. And yeah, which book would you recommend for studying these topics and questions like past papers? Yes. First, I will suggest you some online resources and past papers. We from Let's Unbound, our YouTube has many past year papers solved used, right? So you can see that like SL, HL, AIHL, AHL, many, like about 8 playlists is dedicated for it. You can refer that, Iran Khan. And yes, about the book, I will suggest Hayes Mathematics. That will be a great practice. And yes, past papers, you can refer to YouTube of Let's End. Okay. Any other questions? How is it better than IGSC or A levels? Um, Actually, IB when you're taking, mostly you can if you're going to study in US, right? Yeah. So mostly what I will suggest is these are super curriculum in their own ways. So IB you can, if you're going to pursue your studies in higher studies in USA, right? Those kind of places, I would suggest IB. Okay. But if you're going to do Cambridge, Stanford, like these UK universities, then IGCSE will be the better one. A level that one. Okay. And also, okay, that's it. Right. So thank you so much, everyone, for listening. Great response I got from you too. And yes, thanks again. Have a good day and keep learning. Kanashri, over to you.
Thank you so much. Thank you so much for a wonderful session, Bhavya Lakshmi. We host unique AP, SAT, and IBDB masterclasses every weekend, and we'll be sending out email updates to keep you informed. That brings us to the close of today's session. I have some important links in the chat box I'll be sending across. Please feel free to save them. Also, a special mention to our star students featured in today's slide for their dedication and inspiring progress. Well done. We look forward to welcoming all of you to our upcoming events and masterclasses. Thank you once again for joining us today. Until next time, take care and keep learning.